Hello, everyone. This is Dr. Sharif El-Gamal, and today we are going to continue our work on ETABS 18 to model a structure from the beginning to the end. In our previous video, we modeled the structures. As you can see, we have axes A, B, C, D, and E and F, and the spacing 3, 8, 5, 6, and 1.5 meters, and also horizontal axes 4.5, 6, 6, and 2 meters. In our previous video, we modeled 3 floors, first, second, and roof. In addition to the ground floor, we have a plinth beams. And then at the bottom, at 1 meter under the ground floor level, we have the level of the foundation. We learned together how to define the material properties, how to define section properties for frames and for slabs, and we added all of this in our previous video. Okay, what are we going to include in this video? We are going to continue our work by adding loads on slabs, loads on beams. We make the structural analysis or running the program to check about deflections, cracking, or bending moment, shear force diagram, forces in the columns, and etc. Okay, so let's start. To define loading, we have first to define different load cases. So if you check in the program on define, okay, in this window, go to load cases. You will find by default we have a dead load case and live load case. Dead load and live load, so they are fine. You don't need to touch them. Keep them as is. That's fine. And then go to define again, and then load cases, load patterns, load combinations. So go to load combinations here. So in the previous one, we opened load cases and then go to load combinations. Here, you will find no combinations. You can add default combination based on which code you want, or just a simple thing, you can add any combination you want. So you can say combination 1 or combination 2. Let's say service. Okay, service loads. And then for service load, we'll use dead load. The scale factor or load factor is 1. Fine, we'll not change this. And then add a live load. So you'll go here and choose live load, and also 1 because this is under service load. Okay, serviceability limit state. And then we'll say, okay, so you'll see that load combination 1, which called service loads, is added. Let's make a copy of this combination or add a new combination. Let's add a new combination, and in this case, we'll call it its ultimate. Okay, and in ultimate, the dead load, according to the BS code, we multiply this by 1.4 dead load, and then we'll add the live load. Live load will be multiplied by 1.6. So based on the code you have, you can add any load combinations, or you can add by default using different code based on which code you want, concrete frame design, and then it will tell you which code you want and will give by default the default combinations that you have. Here, we don't need to go to this complication, like only service load and ultimate load will be enough to make our design. So once we finish the service and ultimate load, we can say, okay, that's fine. Then now how to add loads on different structural elements here. Let's start by adding load on slabs. Okay, so for this to be easy, just you can come to this symbol here, and let's remove beams, remove columns, or like close them. So you'll have only the floors will be fine here. Then based on which loads you have it on the slab, we can add the load. So we can select all slabs, okay, in one floor, or also we can select all slabs in all floors, but let's start by floor by floor. Here we are at the roof level at Z, or the height 11 meters, so we start by the roof. Okay, for the roof, let's add a live load and then also add the extra dead load. So we come here, how to add loads, we'll go to the assign. Okay, so we'll go to assign, and then you have joint frame shell. Okay, so for shells. Also, you have shell loads. So we can go to shell loads here and we add a uniform load. So go to assign shell loads and then uniform loads. So you'll have this window here. And if you click here, you have two different loads that is you defined at the beginning, dead load and live load. So let's start by the dead load. And what does it mean here, dead load? This is extra dead load in addition to the self weight. So the self weight is already known and will be taken by the program. Don't add it here because we told the program this is a concrete and the density of the concrete equal that value. So you don't need to add the self weight anymore. So this will be finishing load, any loads due to partitions, or if you have mechanical systems, ACs, all of this will be under the extra dead load or superimposed dead load. So here, let's say this is a roof. Usually the roof you have extra dead load because of the finishing layers you have it on the roof. Okay, let's take it 3.5 kilonewton per meter square and in the gravity direction, and then we'll click OK. So once we click OK, you'll find that the load here is 3.5 kilonewton per meter square on the roof. Okay, in addition to this dead load, we can again choosing them again, and then we'll assign, okay, shell loads, uniform loads, but instead of dead load, we'll add the live load. Live load on the roof is less than live loads on other floors. Let's say it 1.5 kilonewton per meter square based on the code or based also the function of the building. Is this roof accessible or not accessible, and so on. Then we'll say live 1.5, and we said okay. So you'll find that now we have a live load of 1.5 kilonewton per meter square for the roof. We can repeat this for all other floors. So let's go to the second floor and we repeat the same thing here. Okay, assign shell uniform load. Okay, dead load, start by the dead load. The dead load here will be less, let's say 2.5, because this is layers of finishing are less than the layers of finishing on the roof. And then we'll say okay and reselect them again and assign shell uniform load, and we'll go to the live load. Live load in this case will be more. It could be 3 kilonewton per meter square, or based on the function of your building, of course. And let's say apply. So we finished the second floor, and we can repeat this by duplicating this for other floors, or making one floor as similar to other floors, or in this case you don't have many floors, you can define them easily. It's not going to take time. So again, click and repeat what we did here in the second floor. It will repeat it on the first floor, and live load is 3. That's fine. And we said again assign shell loads, uniform loads, and then the dead loads we put it 2.5 meters, apply and say okay. So we assign all loads now on all the 3 floors: roof, second floor, and first floor. These are the loads on the slabs. So now we need to add loads on the beams. On the beams, we have loads coming from the slab. This will be taken directly by the program. So what additional loads we need to add? If you have wall loads on these beams, you need to add wall loads. Okay, so let's start again by the roof floor. This is the roof. And now, because we need to add loads on beams, so we can hide the slabs, and now we can open the beams. So let's go here. Beams will make them open. For the floors, we don't need, or we keep it because we will need to add one beam. Here you can see we have beam here, and then at this outer sides here between 4 and 5 and E and F, you have a cantilever. Okay, and for this cantilever, you will have here a parapet, a small wall here at the outer perimeter of the building. So, okay, you can add this load by adding a small beams here or a hidden beams here at the outer layers here. These hidden beams will not carry any loads because we'll put a small dimensions, okay, but it will allow us to add loads on the edges of the slab, Okay, so to do that, we will we'll come here, draw a beam. Then we'll say, let's select the beam. And here, I added a small beam here, like 150 by 150 millimeter, which is less than the thickness of the slab. And then we'll do it here, and one beam, a second beam, a third beam, and a fourth beam. Okay. You can do it like that. And this will be the last one, in addition to one at the end here. So these are beams. I put them at the perimeter of the building, a small beams, as you can see here, to allow me to put some line loads or wall loads at the edges of the building. So once we finish that, we can add loads now. So to do this, we have to select the beams where we put the loads. So for the roof, let's assume that our loads will be at the perimeter of the building and will be like a 1 meter height wall. Okay. For that one, you have to calculate the self weight of such wall. And let's assume it is 4 or 5 kilonewton per meter. So we are going to select all beams. We select those beams, and then we select here. Okay, this one, and here. So we selected all outer beams that are surrounding the whole roof. Okay, so we selected all beams here, and then we'll go to assign. And instead of shell load, we'll go to frame load. So frame load will use distributed load. And for distributed load, this will be dead load, because walls are always will be dead load. And then we'll put the load here, assuming it is 4 kilonewton per meter. Okay, so let's say 4. I will say okay, and these are 4 kilonewton per meter. If you want to display this, let's go to this screen, and we remove this extruded view. If you want to see the loads here, you will come and display, click on display loads, okay, frame loads, and say okay. You'll find here at the outer perimeter of the building here of the roof, we have a wall loads of 4 kilonewton per meter. Okay, then let's go down to this screen, and then go down to the other floors, assuming here that all walls or all beams will be carrying loads of 3 meters height, or 3.5 or 4, based on the height of your building. Let's assume here it is the wall height is 3 meters. Okay, so we'll come and then making a sign again, frame loads, distributed loads, and we will come here and we'll say 12 kilonewton per meter, and then we'll say okay. If you want to display it again here, come and say display loads, frame loads, and say okay. You'll find here now at the first or second floor, I have 12 kilonewton per meter, and it will be in all beams. However, for the roof, I have 4 kilonewton per meter. So we still have some other beams. Go to the bottom, and we repeat things here. Okay, assign, frame load, distributed load, and say okay. And then the last one will be at the ground floor level. You have the plinth beams here at the ground floor level. Also, they will be carrying walls. So again, assign frame load, distributed load, and 12, and say okay. In this case, if you want to see the loads, come to this screen and say display loads, frames, and say okay. You can see now we have loads on all floors, including the roof at the perimeter, and all other floors we have loads on all beams. If you have a wall, a beam not supporting a wall, so we can remove the load from that beam. So now we finished loading on the slabs, we finished loading on the beams. If you want to see the loads on the slab, again, you want to see anything, go to display and say shell load, for example. I want to see the dead load, so it will give me the dead load at different floors, 3.5, 2.5, 2.5. Okay, if you want to see the live load, again, display load, shell loads, and then we'll go to live loads. So you can see here and check your model. Yes, at the roof, you have 1.5, 3, and 3 for the first and second floors, as you can see. If you have any mistake, you can check it from here and go and repeat the work, remove the load, adding another load, and so on. So you have all the options. So once we finished all loading like this, let's check our model and see if it's okay or not. So how to do that? We have to run the model. Okay, we have to run analysis. So we click on run analysis, okay, or analyze, and we can say run. So let's say here run analysis, and it will take time to make the run. It will start making some calculations, as you can see here, and we'll check and updating, and we're starting by plans and moving from one element to another element, as you can see from this point here. Once it's finished, it will give us the deflected shape and will tell us if we have any errors or what mistakes that we have in our model. So this is the shape. We don't have anything about errors coming to us. So we can see here, this is the deflected shape. If you want to see this in a bigger window, just to close on that one. Okay, you can see it here. And if you want to add another window, you can add a new window here like this, and you can divide it into two windows. So let's keep only one window, and we close one of them. So this is the window that we have. And if you want to start animation, you want to click. This is useful step to see how the structure is working. So why we do that? Because if in some cases you will see, I will stop animation, but in some cases you will see that sometimes some beams will not be connected to columns. So you will see that they will be free, will move up and down, okay, away from the column, or a slab will not be connected to the beam, and so on. So by making this animation, it will give you an idea about if all connections are good, if you are missing a connection at one point, if you need to change the position of the column, and so on. So it looks fine for this one, no problem in our model. So let's move now to see different bending moment, shear forces, and axial forces, and so on, to see how they are working. How to do that? Okay, to check deflection, it is from this one. So this is a deflection. It can give you deflection due to combinations or loading cases. So if you want to get the deflection from dead load only or live load only, you can do that. If you want to get the deflection due to combination service load, for example, you can also do that. And you can draw contours on object if you want, and you can click OK. It will give you different contours. Let's put this on plan, and we'll start by the roof plan, for example. Okay, so these are deflections are very minor here. And let's go back to deflection. Okay, let's draw contours. Okay, wireless shadow, apply. Okay, deflections are small, but if you moved from one point to another point, you can see the values here, 0.15, and here the value will be small, 0.4, and so on. At any point here, you can check your deflection values, okay? But more than important than this one, we can check also the reactions, and we can check the bending moment. The bending moment shear forces, we can get them from here. So let's start by this bending moment and shear forces. So if you clicked on this sample here, you will have different values. You will have M33, it will give you the bending moment. And let's choose combination under ultimate load, okay? And by clicking OK, we'll see the bending moments on all beams. Okay, so you can see here, beams, this yellow refers to the positive bending moment, and the red here refers to the negative bending moment. If you want to see the value, you can move here, or if you want more detail, just right click on that. It will open you another window here, and then you can move to see how much will be the bending moment at different points, shear forces, and even deflections. Okay, so this is for one floor. If you want to move to the second floor, you can move to the second floor, third floor, and so on. This is in plan. Okay, the same for shear. You will click again on the same, but for shear, we choose shear 2 and then click OK, and you will see the shear force diagrams. You can see them on plan, or you can see them also on elevation. Let's say elevation at A, and let's say OK. So it will give us the shear on elevations, or if you want to change again to bending moment, let's go to bending moment, and this is showing the bending moment. And if you want to move from one axis to another axis, okay, this is showing the positive and negative moment at different axes. Okay, this is the last beam, which is the end beam at the roof. Values are very small because they are actually not, we put them only to add the load on the slab. Okay, so they don't have any very small values of bending moment, which is not important. And then also you can move to the other side or other direction of the building, moving from one direction to another direction. Okay, so these are the bending moment and shear forces, as you can see here. If you want to see these as values, so you come here and you show values on the drawing and click. That will give you the maximum values, as you can see here. If we change this to moment again, and we put the values here, show values on controlling, so it will give us the maximum negative moment, maximum positive moment, and so on for each beams. We can use these values if you want to make a manual design, or also to check if your solution looks fine, good, or there is a problem there. Okay, so these are the bending moment and shear forces. We can get them all from this one. Bending moment M33, shear is shear 2, and we'll say okay, and these are the shear values. Now, the last thing, if you want to get the reactions, okay, at the bottom of the column, so we can say click on that symbol here, and we'll say okay, and then it will give you the reactions, as you can see here at the bottom. We can use this value to design for our footings, and you can move from one direction to another direction, or like one one axis to another axis, as you can see, with all values. If you want to see this in plan, you can see it in plan at the base level and click OK. And let's see the values. Okay, this is, click on tabulated values and say OK. And you can see here all the values of loads at the bottom of the columns or above foundation. You can see here at outer columns, like this one, the spacing is not that much. You have 271 kilonewton. However, like middle columns, because they are carrying load from all dimensions, the area is more, so you have a bigger value, 2,783, and so on. You can use these values to make initial sizing of your columns again, and re-changing the column sizes in your model to have like a good design. Okay, because initially we have to put some dimensions of the columns, and you can refine them again if they are not suitable based on these values. Okay, so these are the reactions. If you want to, for example, to see the axial load on the column, also axial force, let's say click on axial force, the same place where we draw the moment and shear, we can get the axial force. We'll say okay, but let's say this on elevation, and we'll go to any of these, and you can see here these are axial force in the column. This is the top floor, and when you go down, the values of load will increase until the maximum will be at the bottom level. Okay, so let's conclude our work here in our model, or in this model. We learned how to add load combinations. Okay, from define load combinations, we added service and ultimate load. Okay, we added external hidden beam at the outer here to add the load on the parapet at the outer side of the cantilevers. We learned together how to add loads on slabs and beams. So to do that, we click on assign and frame load and shell load. Of course, now they are closed because we already run the analysis. And when we run the analysis, you can see the model will be locked. You cannot change it anymore. If you want to make any change, you found any mistake, or you want to make any change, okay, you will not be able to make any change until you unlock the program. So once you unlock, you will be able to make changes again. Okay, so we assign, we added frame loads, we added shell loads, and then we run the analysis, and then we check together how to see the deflection, how to see the bending moment, shear force, axial force in column, and even the reaction at the bottom. This will be the end of our video today, and within the coming video, we'll see how to make a design to know about the reinforcement in the slabs, reinforcement in the beams. Okay, thank you for watching and looking forward to see you in a coming video. Goodbye.